This is question 22 from section 1 of the 2018 ECAA paper. So we're given an arithmetic progression and we're told the first term of this progression is non-zero, that the fifth term is equal to the square of the first term, and the 33rd term is 10 times the third term. And from all of this information, we're asked to deduce what's the 10th term of the sequence. So we've got all this information. What do we want to do with it? Well, let's write it out algebraically to start with, and hopefully that'll help. So we've got an arithmetic progression. So we'll call our sequence Tn. So we know the nth term is equal to a plus nd, where these are difference between terms and a's sort of the zeroth term, so to speak. So we know this is true. We know the first term is non-zero, so t1 is not equal to 0. Well, term 5 is the square of the first term, so t5 is equal to t1 all squared. And term 33 is 10 times the third term, so t33 is equal to 10t3. So this is all our information now in algebraic form. Where we're going to start? Well, it's probably one of these two we're going to sub this into. It's the only logical thing to do. And this one's probably a better starting point than this because this has got squared in, this is just linear. So we'll start with this. So subbing in t33, a plus 33d is equal to 10 lots of 10t3, so a plus 3d. So rearranging that, you get 10a and a, so minus a to 9a, and minus the 30d you get from here from this side. 9a equals 3d, and d equals 3a, just dividing 3 by 3. So this is good, because if we substitute this in here, we get Tn is equal to a plus n times 3a, or alternatively, Tn is equal to 3n plus 1 lots of a, which is a far more succinct form for Tn. It's a lot nicer, because it's only got one unknown in now. So where do we go from here? Well, we've used this, we're going to have to use this, as nasty as the square is, but we'll go through with it. So t5, well, t5 will be 16a, because it'll be 3 times 5 plus 1, which is 16 times a. And t1, well, 3 times 1 plus 1 is 4, so t1 squared is 4a all squared. So what are our solutions to this? 16a equals 16a squared. Well, we get a equals 1 or a equals 0. So that's funny. We want one solution, we got two. Well, we've not used this yet, have we? t1 not equal to 0. And if a is equal to 1, then the first term is 3 plus 1, 4 times 1, 4. So that's fine. But if a is equal to 0, our first term is 3 plus 1, 4 times 0, which is 0, which violates this. And so a can't equal 0. So we've just got a equals 1. So all we've got to do now is find the 10th term when we know Tn is 3n plus 1, because a is 1. So if that's the case, T10 must be 3 times 10 plus 1, which is 31. And so our answer is option A, as that's 31, so A.